It's your friendly math tutor, Miss C here, and today we are expanding our knowledge of logarithms by simplifying expressions that require us to use both the quotient and product property. So let's go ahead and get started. I always like to start by making observations about what I see in problems. So I'm noticing that I don't have a base that's explicitly listed here. So just as a reminder, when we don't have a base that's written, our log is in base 10, the most common base. I also noticed that I have a numerator and a denominator, so that tells me I'm going to have to use the quotient property to expand this out. I also noticed that I have multiplication in the denominator, so 1,000 times x. So we need to use both products to try to simplify this in some way. So I am going to go ahead and I'm going to apply the quotient property first. So I'm going to say the log of 5,095 minus the log of what's in the denominator, which is 1,000x. So this is the simplest way to start, right? I followed my quotient rule, which is when I have the log with the fraction inside, I can rewrite it as the difference of two logs with the first term being what's in the numerator. So now I want to go ahead and I want to break this apart because whenever I'm trying to simplify logarithms, and there's variables, I want to get the variables on their own. So I'm going to go ahead and we're keeping this log of 5,095. And I'm going to subtract from that. So I'm going to do parentheses here because I'm subtracting this whole thing. The log of 1,000. Okay, but here's the catch. Now I'm going to use the product property. And to that, I'm going to add the log of x. So a couple things that are really important here is that I have the log of 1,000 plus the log of x. All of this is being subtracted, right? Because the whole log of 1,000 is being subtracted, this negative has to go on the outside. So now I'm going to go ahead and simplify. So I have the log of 5,095 minus the log of 1,000. So this is base 10. So really what this is asking me is 10 to what power gives me 1,000? And it's 3. So that's simplified. Plus the log of x. Now, I could go ahead and leave it like this, or I could go ahead and distribute my negative through to each of these, and that would also be correct. So I'm going to go ahead and get this into the simplest form, which means without parentheses. So I'm distributing my negative sign to all of these terms. Okay. All right, that is your answer on that one. Let's look at our next problem. Very similar situation, except our multiplication happens in the numerator right here. And this is base 3. So I'm going to start and I'm going to write this as the log of base 3 of the numerator, so 81b, minus the log base 3 of my denominator, which is 126. So I still have a multiplication in the numerator, so I'm going to want to deal with the fact that this is being multiplied to get the variable by itself. So I'm going to say log base 3 of 81. And now my property says I add these together, log base 3 of b minus log base 3 of 126. So I think I can simplify just a tiny bit more because log base 3 of 81, I'm pretty sure 3 to some power equals 81. So I would want to simplify that. So 3 times 3 is 9. So that's 3 to the power of 2. 3 times 3 is 27. 3 to the power of 3. 3 times 3 times 3 times 3 is 81. So I know this ends up equaling 4 plus log base 3 of b minus log base 3 of 126. And 3 to some power does not equal 126. So I'm going to just leave this as is. And then if this was an equation, I would simplify it at the end. Okay, I'm going to go ahead and clear the screen and do our last problem. So in this problem, we have the log of 7, base 7 of 63a divided by 125z. So we have the power property, or the product property in, not the power property, product property in both the numerator and the denominator. And then because this is being divided, I know that I also have the quotient property that I need to use. So I'm going to come clear over here, and I'm just going to expand this using the quotient property. So my base also is base 7, so we need to make sure we write the log of base 7 on all of these. So the log base 7 of 63a minus log base 7 of 125z. Okay, that's our first step. Now our second step is going to be expanding the product property. So log base 7 of 63 plus log base 7 of a. So great. We've broken apart the 63 and the a. So if we needed to get the log base 7 of a by itself, we could do that for whatever reason. If we're simplifying an equation or solving an equation, minus, and I'm going to put a parenthesis here because this minus is going to carry through to both terms, log base 7 of 125 plus log base 7 of z. So I'm looking, 7 times 7 is 49, times 7 is not 63. So be careful here. 7 times 9 is 63, but this is not what it's asking. It's saying 7 to what power is 63, not 7 times what number is 63. So I can't simplify log base 7 here. So I'm going to leave this as is. So this term gets to stay. I also can't simplify log base 7 of a because it's as simplified as it gets, minus, okay, 7 times 7 times 7 is way bigger than 125. So again, 7 to some power does not equal 125. So I'm going to leave that just as is. And remember, this negative applies to both of these terms. So I'm carrying my negative through to log base 7 of z, which is already as simplified as it gets. So this would be our simplified expression. So when we're doing these in isolation, it's hard to see how these are useful in the long run. But trust me, knowing these properties are going to give you a lot of different options when you get into equations in which you have to manipulate how the equations look to be able to solve for the variable. And when logs are involved, this is one of the easy ways to do it, is by applying the product or quotient property, or both, to get your terms separated. All right, that is all for today. Please like this video if you found it helpful, and make sure to subscribe for more math content. As always, remember, you've got this.